Other than that, welcome everyone to session 2A of the 2022 FASP hackathon. Today's session is getting started with DataConnect. My name is Fizz. I work for DNA Stack, and I'll be your host for today. So as I mentioned to some of the people who were here earlier, this session is intended for those who are familiar with the concept of DataConnect and now want to run it on their own machines for the first time, maybe connect it to one of their own data sources. To that end, in this session, we'll do a brief overview of what DataConnect is, how it works, and particularly how the reference implementation works. We'll discuss how to acquire and build a source, or if you want to skip that, just to acquire the Docker images you need directly. We'll discuss how to deploy and configure Trino to connect to your locally running data source. And then finally, we'll discuss how to configure DataConnect to connect to that Trino instance that we're going to set up. I sent a link in the chat, which is a repo you can follow along with. It contains a README with all the commands I'm going to be running in my terminal today. It also contains some of the files that I'll be writing by hand, so you can just use them directly. But I will be writing them by hand so you can understand everything that goes into them. All right, before we dive right in, any questions about the premise? Sweet, let's go for it. So some of you have probably seen a slide that looks like this before. The TLDR is that DataConnect is a standard which attempts to simplify interactions which typically look like this, or once upon a time look like this, where on one side of the fence you have these many data producers who will have different APIs for interacting with their data. They'll store their data in different mechanisms physically underneath. They'll present data to consumers in different formats. And on the other side of the fence, you have the same thing from the data consumer side, where they're compatible with different data sources. They require data to be in different shapes, depending on who they're talking to. They have different auth requirements. And so the flow of your data is kind of like this complex network. DataConnect attempts to take those interactions and simplify them into one that looks more like this, where there's a standard API where consumers can request data, and there's a standard mechanism through which data producers can surface their data. And that's reflected in 4 endpoints that DataConnect surfaces. The first is the tables endpoint, which enumerates the data which exists under your DataConnect instance. There's a table info endpoint, which allows you to request the data model associated with a specific table or table itself. There's a table data endpoint, which allows you to request the entire contents, like the actual data contents of a table itself. And then there's an optional to implement search endpoint, which allows users to write SQL queries to ask specific questions about the data, including doing things like joins across data sources and all that kind of stuff. So the implementation of DataConnect we're going to talk about today is DNA Stack's reference implementation. It's called DataConnect Trino because it's built on top of Trino, which is a distributed query engine, which is intended to allow you to use one query language, which is SQL, to query many disparate data sources, whether that's like a Postgres instance or BigQuery or Google Sheets or just a file in a bucket. There's a connector that exists for Trino. You can ask questions of that data through SQL, and the DataConnect Trino implementation lives on top of that Trino deployment in order to turn the responses from Trino into the DataConnect standard format. It also accepts API requests from consumers to translate them into requests for Trino, which then get forwarded on to the data source underneath. This provides 2 real benefits. One, for data consumers, you get the standardized format in which all data is returned. So then you can start building tooling on top of it because it's a standardized container. There's a schema associated, so you can understand the data. And also you can ask questions in a very standardized format, regardless of what the underlying data source is using SQL. And on the other side of the coin, for data producers, they get the benefit of being able to surface their data in this standardized interoperable way without actually having to transform their data underneath, right? You don't have to go and write queries that will change the shape of your data in order to get it surfaced through DataConnect. Okay, that's the 5-minute recap of DataConnect and how it works. The important thing to remember is that the reference implementation leverages Trino, the distributed query engine, in order to make requests to the underlying data sources. If we're all okay with that, we can actually go ahead and get started in trying to deploy some of these services ourselves. And I will share a link to this deck at the end of this session. The last slide includes a link to a bunch of resources you can use to further explore DataConnect. I'm gonna go ahead and open up my terminal here, make it a little bit bigger so we can see it properly. What do you guys think? Is that big enough? Clear enough to read and see?
Very good.
Awesome. So I've created a little directory here, which is the FASP hackathon directory where we'll be doing all our scratch work. And so we're going to do a few things here. Like I said, first, we're going to download and set up Trino. Second, we're going to set up a Postgres instance, which contains some data that we care about and connect it to that Trino instance. And then finally, we're going to set up DataConnect to point to that Trino instance so that we can get access to the data in the underlying Postgres instance. So to begin with, if you're following along at home, I'm going to run this script, which is going to install the Trino CLI for me. If you want to see what it looks like inside, it's just downloading an executable and making it executable, putting it in my bin directory so I can execute it. And now if I run Trino, I have a CLI. If I try and run any Trino commands, it will error out because I don't have a Trino instance running. So let's get started with that. So the Trino organization actually published a Docker image you can use at trinodb/Trino. So I'm going to go ahead and pull that. You'll see I already have it. And getting it started is as easy as running Docker run. I'm going to give it a -D to make it run in the background. I'm going to port forward the default port that Trino uses, which is port 80 when it's running, so that I can access it from my local network. I'm going to give it a name. Let's call it FASP Trino for our demo instance, and then the image I'm running, which is trinodb/Trino. You can see it started, and there it is. If I go back to my Trino CLI now, by default, it will try and connect on localhost to port 8080 because that's the default port that Trino runs on. If I do something like show catalogs now, you can see that it's connected to my instance correctly. And it's actually what it's showing to me are some default catalogs that Trino surfaces. For example, this memory catalog is exactly what you would expect. It's an in-memory database with some default tables. There's no data populated within them, and we actually don't care about them because we're about to blow these away really quickly. So with that, we started Trino running on our local machine. And by default, it had some data sources that it started with out of the box. Next, we're going to configure a new data source. Now, Trino is a little bit interesting in that, unlike many modern applications, it doesn't use environment variables to configure itself or determine like what its runtime configuration should be. Instead, it reads files off the file system to determine like what data sources it should connect to when it stands up. So we're going to take a quick look at that Trino file system to gain an understanding of like how it's actually configured to talk to data sources. I'm going to run a quick Docker exec command to get into that container I was running with a shell. See if I do an ls here. Here I am inside that container. And we're specifically going to look into etc. Trino, and we can see that here are a bunch of files which describe how our Trino instance is configured. There's a jvm.config, which gives it the JVM various properties. There's logout properties, which shows Trino what level to log at, and you can see it's by default debug. And in this catalog directory, we have various properties files. And if you were paying attention, you might notice that the names of these properties files correlate exactly to the catalogs we were seeing when we were connecting with the CLI. We don't actually want any of these there, so I'm just going to go ahead and remove all of these. There's nothing here anymore. Now, if I exit and I restart my Trino instance, when I reconnect with the CLI, which will probably take a second because the instance is booting back up. It is still initializing, We can see that like our catalogs have gone because the files are no longer there. The system catalog is available by default. The next thing we're going to do, now that our Trino instance is A, up and running, and B, doesn't contain corrupt data sets that we don't care about, is set up an actual data source that we do care about. And we're gonna do that using Postgres. So let's start up a Postgres instance on our local machine. I'm also going to run it in the background using this -d command. Let's give it a name like FASP Postgres. Let's do a little bit of port forwarding on the default port that Postgres runs on, which is 5432. And finally, we're gonna give it one environment variable, which is the default administrator password. And because we're lazy, we'll also just make the Postgres. Finally, the image name that we're running, which is once again Postgres. We'll give that a run. We'll check out Docker PS, and we'll see that hey, our fast Postgres instance is indeed up and running. Now, if you sync this repo, you'll notice that there's a DataConnect test database in this directory that you can use to populate that Postgres instance. There are some commands within the README that I suggest you run first, which I'm gonna run here, which are to create the database and the users before you input the data. So let's do that. We're gonna connect using PSQL to our localhost on port 5432. That's where our Postgres instance is. Our user is gonna be the Postgres super user. It's gonna ask for our password, which is Postgres, and here we are. I'm going to create a database, the database that I'm about to import the contents of. So it's the PHP dataset service. Let's create a user for it. User, and then let's grant him all permissions. All right, with that, I've created my user, I've granted him all permissions on the database, and so I can do something like this and import my data. On port 5432, we're going to import a file. Service, and we're going to import a file, which is the test data. And there we go. It imported them all. It gave me a few errors because I didn't create all the users that are necessary, but that's not important for our test scenario. What is important is that our data is populated. Oops, I didn't do that. Let's go back to fast. 2, make this bigger again. All right, so what have we just done? We start up a Postgres instance on our local machine. We created a database in it, and then we've populated it with some data. So now we have a Trino instance that's running, and we have a Postgres instance that's running. And the next thing we're going to do is we're going to tie these two together. So like we said, Trino instances are configured by files that exist in the file system. And connectors are configured by these .properties files, which exist in the file system. Every properties file has a slightly different shape depending on the data source you're trying to connect to. We're going to be connecting to Postgres, but as you can see, like on screen, this is the complete list of connectors that are supported by Trino. So if your data source is not Postgres when you're trying this out, just go find the one that find the data source on this list that your data source is, click it, and it will tell you how to configure the properties file in order to connect this connector. We can see from this page that Postgres properties file has 4 lines. It's the name of the connector we're using, which is Postgres itself. It's the URL to connect to the database to. It's the username to use and the password to use. Let's go ahead and write that. So I have one written here, which I'm actually gonna delete because let's write it by scratch. Let's take our sample. Let's edit it so that it meets our need. So our connecting name is still Postgres. Our URL is not example.net. It's not where our Postgres instance lives. Because we're running it on Docker, we're actually going to take advantage of the Docker internal network, which is host.docker.internal, because that's how we'll access our Postgres instance on port 5432. And then our database name is not database. It's PGP data set service. Same with our username. And same with our password. And that's all we need. So we're going to go ahead and write this. And now we have a properties file that will tell Trino how to connect to our data source. The last thing we need to do is actually put it in the correct spot on the file system so that Trino, our Trino container will pick it up. We can actually just copy it directly into the container using Docker copy, doing something like copy our properties file into our container, add etc. Now, with that copied in, if I restart the Trino instance, it will pick up this file on reboot, which will tell it to connect to our Postgres instance, which is already running. So if I restart the CLI, I check which catalogs exist. I can see that my FASP catalog has appeared. Check the schemas inside. We have some schemas. In the schemas, we have some tables. And we can do something like and there we go. Okay, so what we're seeing now is that we've set up a Postgres instance locally, we've connected Trino to it, and using the Trino command line tool, we're exposing that data through Trino, basically proving that Trino is actually talking to our data source. This is our Postgres data source. Okay, that's step one. Now, if we go back to like our little diagram of what the infrastructure looks like, we've basically set up this half down here, where Trino is now talking to our data sources. The next step is to set up DataConnect, so it's talking to that Trino instance, and then you can expose this data through the DataConnect API, which we're going to do next. Let's exit out this. Let's exit out the CLI. Next thing we're going to do is we're going to require the source code of DataConnect Trino itself. There is a pre-built Docker image, which you can use. I do recommend you get the source itself and build it because it's going to be the latest. The Docker image is a little out of date. Let's go ahead and clone the DataConnect Trino source, go into it. And I'm going to take advantage of a script that exists within the repo, which will help me build the Docker image really quickly. So all I need to tell it is what I want the image to be named. I'm going to build it. And on my machine, because I've cached, I've built it before, so it built really, really quickly. On your machine, it might take a little bit longer, but I have a Docker image that I can use. Let's start it up. Before I can start it up, DataConnect Trino does require its own Postgres instance, or like it does require a Postgres database to connect to. So let's make sure that that exists before we boot this up, so that I can connect to it on startup. So let's go ahead and connect back to our database. And here we're going to create the databases required by DataConnect Trino. Database itself. Let's create the user. Let's give all permissions. I type this. Oh, give all permissions. We're done. And now, so now when DataConnect Trino starts up, it will have a user account it can use in the database and connect to our Postgres instance. And the last thing we're going to do now is we're going to start up DataConnect Trino. So we have Trino running, we have our Postgres instance running. So let's run. We're going to call it FASP DataConnect to give it a nice name. We're going to expose the port that DataConnect Trino runs on by default, which is 8089. We will pass it some environment variables, the first of which is where to connect to Trino. We're once again going to take advantage of the Docker network, which is hosted at docker.internal. And we know from earlier that it's on port 8080. We're going to tell it via the Spring data source URL environment variable how to connect to the Postgres database it should use for its own data, which we know is running on port 5432, also on the Docker internal network. So and the database name is DataConnect Trino that it should use. And then finally, we're gonna enable a Spring profile, which is gonna disable the auth requirements on DataConnect Trino. This is so that when you're running it on your local machine, you don't have to log in or anything or give it an access token. It will just let you in as an anonymous user. Spring profile is active is the no auth profile. And then the image we're trying to run. Trino latest. Oops. I did this before and I should have cleaned up after myself. So let's remove FASP data and let's start it. I didn't run this one in the background, so you can see it is actually booting up instead of just disappearing behind a hash. Did I typo the password here? Second. Let's just do this again from scratch.
I think there was, when you were doing the drop user, you had DataConnect Rhino. It was missing the extra T.
That got me, and that's why I wrote this all down. So in case I did make errors, I can just copy paste a bunch of stuff in. Okay, that should do it. Let's rerun it. This time it started up correctly because I didn't typo the password. Should be running on port 8089. We're going to check out the tables at point. And we can see in our response, in this JSON response, that the connector we added, the FASP connector, is available. And the tables we enumerated are available through this endpoint as well. Here we have a link to the info endpoint, which I alluded to earlier, which gives us the data model, which is associated with our data. And we can also change this to the data endpoint, which will give us some pagination links that we can follow and will eventually return to us the actual contents of our table itself. And with that, we're done. We've successfully connected our data source through Trino, and then connected Trino to through DataConnect Trino in order to surface our Postgres data in a DataConnect compatible format. Yeah. Okay. Questions about that? I do have some resources that I'm willing to share with you, including the link to the repo that I used that contains the commands I ran, the link to the deck I shared, which I will share with you right now, actually. Other than that, that's all you need to know. From there, if you want to add your own data sources, right, you can modify. If it's a Postgres instance, you can modify the properties file we wrote together. Otherwise, you can go back to the Trino documentation to learn how to set up a connector for your specific data source. Yeah. Questions, comments, concerns?
Can I
That was
have,
awesome. Oh, sorry.
go ahead, Max. I can ask next.
I was just going to say, for posterity, for any Linux users who end up watching the video we record later and trying to follow along, you do have to change some of the host.internal special domain
Oh.
name to localhost, and you can change all of the Docker run commands to use the -- network equals host. But I expect there are going to be fewer of us Linux users following the steps than Mac users.
That
Yeah, and
should
if you
be-
are a Linux user, you signed up for solving your own problems. So
That's true. I accept that.
I think what Max just said should be covered on the getting started website for DataConnect. The differences between if you're running on Mac or Windows versus Linux.
Right. All right. I'm just sharing some links in the chat. Yash, you had a question, I believe.
Yes. I was curious, like, can I have two different connectors? Like, should I put them in the same property file or have two different properties files or two different Trino instances?
Have two different properties files. So the name of the property file, like before the dot properties, it's what is used to infer the name of the catalog that you see in Trino itself. So you want a distinct one for each catalog you're trying to surface.
Makes sense. Got it. Thank you.
But yeah, you can put like 100 properties files in that one directory and they'll all be served by the same Trino instance. You don't have to boot up a second one.